I'm going to talk about more algorithm detail. We have two simple ways to get information from our graph: get start node and get nodes. When we use this graph, we can easily find out where to start and see all the nodes we can visit. This graph is super useful when we want to find the quickest way to get from start node to another. And this program is built as a Java Swing GUI application to visualize breadth first search on the graph. This architecture follows as a simple model view controller pattern, and there are 5 overview functionalities I will show you later. So this whole thing is built using a Java class called graph panel, and inside this class there is inner graph panel class. Let's break down. Graph panel, this is the first thing that runs when the graph starts. It gets everything set up, including the graph and the window. It sets the title, size, and tells the computer to shut everything down when you close the window. It also calls 2 important methods to organize everything: init components and layout components. Init components is set up a drop-down menu when you can pick a node, a button to start the search, a label to show how many memory is used, and it creates a place on the screen to draw the graph. Layout components. After all the parts are ready, this method arranges them on the screen. It puts the drop-down menu and button at the top, the graph in the middle, and the memory used label at the bottom. Perform search. This is where the action happens. When you hit the search button, this method gets to work. It figures out which node you picked, clears any old colors for the graph, checks how many memory the computer is using before and after, and updates a label to show that information. And the search string value, this is the most important part. I'll show you later. It does the breadth first search. First, it sets up a queue and puts the starting node in a queue. It colors the start node orange to show where the search begins. Then it checks each node in line one by one. If it finds the node you are looking for, it turns it green and stops. If not, it adds any new connected nodes to the queue and keeps going until it either finds the node or runs out of things to check. And in the inner graph panel, pet component, it also sets the colors based on what's happening during the search. For example, if a node is being checked, it might turn red, and if it's finished, it might turn green. Draw edges. This method helps draw the lines that connect the nodes. Draw node function. It picks a color based on what's happening, like orange if the node is waiting, red if it's being checked, or green if it's found. Get node position. For example, node A might be at the top, while B and C are below it. The position is important because it helps us see how the nodes are connected. And according to the feedback of professor, I changed my perform search function part. This original version of the node worked fine, but there were a few things I thought could be improved. In the original code, whenever the colors of the node changed, we have to keep repeating the same lines of code to update the visuals. The same block appeared many times, so we, instead of writing those lines over and over, we just write one line. And on the other hand, the original code, we only checked if the current node was the one we were looking for. But what if its neighbors was the one we are looking for? So it would take longer to find them because we wouldn't check until later. I updated the code so we can find the node we are looking for. While we are adding neighbors to the queue, we can stop right there. Now I'm going to show you the live demonstration. The start node is node A. If we need to search node C, then we will visit node A first. Then we visit node A's neighbors. BCDE, so the Q is BCDE, but the node C is our target node. So we visit node B and node C, then we should stop because we find our target node. And then we don't need to continue to visit node A's other neighbors. And there are some information of the memory used. Now I'm gonna show you the node M. If we need to search node M, M is connected with node L and node E. Node E is the second level, so we have to visit until the second level. We visit node A first, then we visit node A's all neighbors. After that, we visit node B, C, D, E's neighbors. When we visit node E's neighbors, we find node M, then we should stop. We don't need to continue to visit node L's neighbors, node O. Then we can see some memory used information here. Thank you.